Alright, before we get started, please take out your notebooks and open up to point number 12. We're just going to go over point 12, point 13, and point 14, and I'm going to highlight some things that you guys seem to miss. What I will say is this, though. When I gave you the study guides, it seemed like as I was grading them that a lot of you just wrote the bare minimum. You didn't actually truly try to answer what I was asking, and I kind of get the feeling that you were just writing to finish an assignment, which is understandable. It's what I would have done too, but if you really want to learn the information, you have to do more than that. You have to actually read it and try to comprehend it, and not just write exactly what's in the book, because if you write what's exactly in the book, you're not going to remember it. Alright, the first thing you need to understand about temperature is that temperature measures an average. So think about the water in this bowl. All temperature is a measure of the average motion of the particles in the water. That's it. Average motion of the particles in the water. Think about that for a second. You have all these particles moving around in this water. Now, a movement's called kinetic energy. All temperature is the average motion of those particles. So think about, first of all, what temperature is. So now that you can really realize that temperature is an average, think about this. With this bowl of water here, it doesn't matter how much of it I have. If I have a little bit here and a lot here, they're still going to have the same average. Remember, temperature measures the average of the motion of the particles. So if these particles in here are moving at a certain average, say they have a 86-degree temperature, and I take water out of it, the particles in here are still going to have the same average. So temperature doesn't depend on the amount of a substance. That's the first thing you really ought to know. Now, when we heat these particles up, say by this light here, what happens is the particles start moving faster and faster and faster. That means that their kinetic energy rises. So think about this. When something is heated up, the particles start to move faster and their kinetic energy rises. At the same time, when particles are cooled or put in a fridge or a freezer, the particles begin to move a lot slower and the water loses kinetic energy. So when particles or the water is heated up, the particles move faster, they gain kinetic energy. When particles are made colder, like put in a fridge or something like that, they move a lot slower and they lose kinetic energy. Let's try to remember that one if you can. So that being said, a hotter object is always going to have more kinetic energy than a colder object. The temperature of a hotter object, obviously, you guys know this, everybody knows this, the temperature of a hotter object is higher than the temperature of a colder object. However, that's not true about thermal energy, and a lot of you seem to confuse this on the test. Where temperature is an average, thermal energy is a total. It's the total amount of kinetic energy in a substance. So, if you had these two amounts of water that were at the same temperature, this one would have a higher thermal energy because there's a lot more molecules. See, it's not an average, it's actually a total. So, this is where it gets a little bit tricky. A hot, boiling water would have less thermal energy than an iceberg because an iceberg has so many more molecules. An iceberg is going to give off a lot more heat than, say, a boiling cup of water or a boiling bowl of water. So you have to really be able to understand the difference between the two. A lot of you seem to get confused about this, but remember that thermal energy is a total, kinetic energy is an average. So these molecules in an iceberg would be moving a lot slower than, say, the molecules in a pot of boiling water. But there'd be so many of these molecules that though their average or their temperature would be a lot lower, their actual thermal energy would be a lot higher because there's so many more molecules in an iceberg than in a little cup of hot water. So their temperature would be lower, but there would be a lot more molecules, which means that the thermal energy would be higher because there'd be more molecules. So an iceberg has more thermal energy than a cup of boiling water, but a lower temperature. And an iceberg would have slower moving particles than a cup of boiling water, but though they're slower, there's so many more of them that it would still give off more heat than a cup of boiling water. So that was, I know, a little bit confusing, but it is something that you have to understand, so you might want to restart the video or whatnot, or rewind it a little bit. Last but not least, you guys remember this experiment from class. You have the rod up top that I'm going to raise the temperature of by putting it under flame, and the other rod that's going down is going to move, and you can see it moving right now. Although it's slow, you can still see it moving. All that's happening now is when the metal rod at top is heating up, it is expanding. So as temperature increases in a solid, the volume also increases or expands. If you watch very closely, you can see how the bottom metal rod is actually moving because the top one is expanding. Now I actually put this rod in the freezer because, as you know, when you put something in the freezer, its particles slow down and it's as small as it's going to get.